Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today, I want to discuss about the problem solvings on SNMP network management concepts. Here, problem solving on SNMP network management concepts. The problems and solutions on a SNMP network management and the concepts. Here is the problem. The first the problem is inefficient network monitoring is a problem in networking. Here is the problem is simple network management protocol, that is SNMP, simple network management protocol. So it is used for monitoring the devices on a network. Generally, with help of this SNMP, we can monitor the devices. Whatever the devices are connected over the network, it will be monitored generally. So suppose if it is inefficient, the monitoring is well and good, it is no problem. Suppose if it is inefficient, the data, the communication, the problem will be arise generally. However, when the network grows in a size, SNMP may become the inefficient due to the amount of the data being pulled, leading to the network congestions. That means using the SNMP instead of the continuous polling, by using SNMP traps, with help of these SNMP traps to send the alerts when a significant events are occur. These reduce the load on a networking devices. Next, implementing the SNMP v3 version, which upgrade to the SNMP v3, which offers the better performance and better security the features which including the encryption and authentication. Here, with help of this SNMP v3, better the performance can be achieved and security the features can be done. Security features, how can you enhance the security means with help of the encryption and authentication technique. So encryption technique, what it is doing, which is converting the whatever the data we are transferring, that data can be converted into the unknown form. So that is a encryption technique. With help of this the encryption technique and authentication can be done with help of the user ID and password mechanism. So if it is the user is a valid user, the users are the authenticated users. So those are the users can able to see the content. They are only eligible to allowing into the system. So that is the authentication authorization can be done. Optimizing the polling intervals. Polling intervals now, how would you optimize the polling intervals means now, we'll adjust the polling intervals based on the critical of the device. That means criticality. That means critical devices. Critical devices can be polled more frequently. Here, while less critical devices can have the longer intervals. That's why it is more frequently the polled means the interval for critical devices, the interval is a very less. That's why now optimizing the polling at the interval like this. Use the sub-agents. Now sub-agents, how can you use the sub-agent means deploy the sub-agents to distribute the monitoring load. Now we'll distribute the monitoring load and reducing the burden on a central SNMP manager. So with the central SNMP manager by using the sub-agents. Problem 2, security concerns in a network management, simple network management as a protocol. What are the security the problems means here? SNMP version 1 and 2. So which is having the limited security features. That means now if you take the SNMP 1 now, which is having the limited number of other features, which is making the network vulnerability. So network vulnerability now, if it is the network is vulnerable, so any hackers can attack your the data attack your the network now hacks the information. So this is a problem. So that's why SNMP version 1 and version 2, which is having the limited security as the features, such as the unauthorized the access and data the breaches and spoofing. For that now, the solution is, for this the problem, the solution is, now we are implementing the SNMP v3, version 3 as the protocol we are implementing. So which is this version protocol now, which is upgrading the SNMP v3, which is provide the robust the security features. Security features like manage the, here is, which is upgraded to the SNMP v3, which provide the robust security features. Now which is like the message integrity and authentication and the encryption. So these are all the security features. Access control. Access control means here, so we have to configure the access control list. Now we have to configure the access control list to restrict the SNMP access to only the trusted devices and administrators. Use strong the community strings. Here is, if SNMP v1 or SNMP v2 must be used, which is ensures that strong unit the community the strings are confirmed. That is that will be the configured. These the community strings will be configured, and avoid using the default the public and private strings. Firewall the configurations. This is another solution. Properly configuring the firewall to allow SNMP traffic only from known source to block any unauthorized SNMP request. SNMP request. Here is next the problem is complexity in managing the SNMP MIB database. That is a management information base. So this is the problem. The complexity of the managing the management information bases can lead to very difficult in a efficient monitoring and controlling the network devices. Here is efficiently monitoring and controlling the network devices. The solution for that one is use the MIB browser. Now which is employ the MIB browser tool to easily navigate and interrupt the MIB, which simplifies the management of the SNMP devices. SNMP devices now which is will be simplified. Organizing MIB files. So which is maintaining an organized repositories of the MIB files, which is ensuring that the latest versions are rapidly available. Now custom MIBs. Custom MIBs now generally we can develop to specific identified the networks, which can streamlining the monitoring and providing the more relevant data. So that is a custom MIB now we can utilize for this, resolving the complexity in managing SNMP MIB database. Automated MIB database compilations. That means here implementing automated tools that compile MIB and integrated them into the SNMP management system and reducing the manual errors. So this is the solutions for reducing the complexity in SNMP MIB database. Next, the problem is inaccurate network performance data. Inaccurate network data performance data, that means the problem is the data, whatever the data is collected via SNMP, so this might not always accurate. Here is the data, whatever the data it is collected here, so it is may not be the accurate always. So that means that the network the performance due to the time delays and packet loss or data corruptions. That means the solution is increase the polling the frequencies. By increasing the other polling frequency, it will be resolved. Increase the frequency of the SNMP the pollings for very critical metrics to get more up to date the performance data. Here is use the redundant the polling. By implementing the redundant polling mechanism, now verifying the accurate data being collected. By with help of the redundant polling the mechanism, we can verify it. Monitoring the SNMP traffic. So by monitoring the SNMP traffic itself in a network, it may be the private network or public network, resolve the any issues in a private and public networks. So with the data collection such as the packet loss or delay, so that can be packet losses or delay can be identified in a private and public network, that can be resolved. Use the complementary tools. So here is use complementary tools means now combining the SNMP with other network monitoring tools. So like NetFlow or SFlow. So which is cross verify the network the performance data to ensuring the accuracy of the network device. Overhead and scalability issues in a large networks. Generally, large networks now, large number of that means it may be the public network or private network. In a large networks, SNMP can introduce the significant overhead. So which is introducing the significant overhead. So which is making it challenging the scale effectively. Scale effectively. The solution is the hierarchical SNMP management. Now, hierarchical SNMP management, now what we are doing, implement the hierarchical SNMP management. Here is implement the hierarchical SNMP management architecture. So that here, where are the multiple SNMP managers, which is handle the different segments of the different networks, which is reducing the overload on a single manager. So with help of this hierarchical SNMP and the management, overhead and the scalability issues can be resolved in a large networks. The segmentation of the network also is another solution. Segmenting the network into the smaller or more manageable. Smaller or more manageable. Here is each with its own SNMP manager to improve the scalability. Using of the SNMP, the aggregators. Now deploy the SNMP aggregator. So that will be the collect and process the SNMP data from multiple devices. SNMP data from the multiple devices, reducing the number of SNMP requests. So which is sent over the network. Optimize the SNMP queries. Minimize the amount of data requested by the SNMP queries. Which is focusing on the very complicated metrics. Generally, these metrics can be considered in a complex network, which is avoiding for the unnecessary the informations. Whatever the information now we are querying for the unnecessary information, with help of this optimized SNMP queries now that can be eliminated. Here, these are the problems and solutions, which is providing the comprehensive overview of a common challenges which will be faced in implementing, managing the SNMP in a network environment, along with the practical approaches to mitigating these issues. Here, real-time problems are: first problem, delayed alerts in a critical networking failure. Now, if any network is failed, some of the alerts will be delayed. So this is a problem. In a real-time network management scenario, delay the alerts due to the polling of nature of the SNMP. That can lead late response to the critical network issues, which is causing the downtime and the potential of the data loss. So this is the problem, and the solutions are that problems can be resolved by implementing the SNMP traps for the real-time alerts. SNMP traps for the real-time alerts using the SNMP traps instead of the relying slowly on a polling. The traps are synchronously notifications. It will be sent from the managed devices to the SNMP manager. Next, the solution now, which will be configuring the real-time monitoring tools. By configuring the real-time monitoring tools now, it will be resolved. So that means these are the tools that can process the SNMP traps and generate the instant alerts through the emails, SMS, other communication, other channels. Prioritize the alerts based on the severity. Set up the alerts as a priority based on the severity of the issues. So critical alerts should trigger immediately the actions, while less the server issues that can be queued for later analysis. Next problem is real-time network congestions due to the SNMP traffic. So if it is the SNMP, the traffic is very high, generally the network congestions will be arised. In a real-time monitoring environment, the constant flow of the SNMP traffic can be contribute to the network congestions, particularly in a large or busy networks. Solution for that one is throttling the SNMP traffic. Implement the traffic shaping or throttling mechanism. So these are the throttling mechanism. Now, to limit the amount of the SNMP traffic during the peak network usage times and preventing the congestions. Utilize the SNMP the aggregators. Use the SNMP the aggregators to collect and consolidate the SNMP data from the multiple devices before sending to SNMP manager and reducing the overall network the traffic with help of the SNMP aggregator, and segment SNMP traffic with help of the VLAN dedicated network segments. So if SNMP the traffic can be overcome, which is isolated from the other network traffic, reducing the risk of the congestions. So now risk of the other congestions can be reduced. Optimizing the SNMP data collections. Now focuses on the collecting only on the most the critical data in a real time and scheduled less the critical data other collection. So during the off peak hours to balance the load. The textbook is SNMP V2, V3 and or M1 2 by the William Stanley. So this is about the SNMP network management concepts, problems and issues. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.